Good evening, students. Welcome to our Guru Chemistry classes. I am Dr. Shankaran and I'll be teaching you organic chemistry and a part of inorganic chemistry. Now, today it's a specimen class that we are going to learn a very important chapter in organic chemistry, namely general organic chemistry. The entire general organic chemistry is very important. And in that, we are going to learn a part of general organic chemistry, namely isomerism. Now, this learning of isomerism definitely will help you understand many more concepts in organic chemistry, like, for example, IUPAC name. You are going to be thorough and you are going to learn how catenation takes place. Now, this catenation and isomerism are an important concept in organic chemistry. And we have class today from 5 to 6 p.m. 1 hour class at a stretch. Though in the syllabus content I have written too many topics on that, my intention is not to rush through all the topics. But whatever topic I am going to do, I shall do it slowly so that all of you are able to understand, follow lecture. The chat box is open. You may send your questions during the class to the mentors. They in turn will forward them to me. I shall answer them then and there. Okay? So with that small introduction, wish you all good luck, my dear students. I once again welcome you all to our Guru classes. Let's go into the session. Isomerism, and in that there are two types of isomerism. You have it here, stereoisomerism and optical isomerism. We are going to do only structural isomerism and stereoisomerism. Sorry, there are two parts here, structural isomerism and stereoisomerism. Stereoisomerism is much bigger than structural, and it deals with optical isomerism and geometrical isomerism, more important advanced level of isomerism. But today we are going to concentrate only on the structural isomerism. And this is, what are isomers? Isomers, they're different compounds with the same molecular formula. Different compounds, they are ultimately different compounds, but they have the same molecular formula. And such compounds are called isomers, and that phenomenon is called isomerism. It's a phenomenon in which different compounds have the same molecular formula, but different structural formula. Because of the different structures, they have different properties also. And the structural isomerism again can be learned in terms of functional isomerism, chain isomerism, position isomerism, metamerism, and tautomerism. Let us take up each one by one. Structural isomerism. As I told you, the definition for isomers, they have the same, different compounds have got the same molecular formula with a different functional group. They have got different properties because they're different functional group. Now you should know here what is meant by a functional group, and that is the characteristic aspect of organic compounds. They are the atoms or group of atoms. For example, these are halides, fluoride, bromide, and iodide. Our OH group is called an alcohol, and this is called an aldehyde. Any compound containing CHO is called an aldehyde. Any compound containing only CO is called as ketone. Any compound has got COOH is called an acid, more so carboxylic acid specifically. This is called an ester. So these are the different functional groups, and because of them, they have different properties. For example, let me take a compound has got COOH, it's called a carboxylic acid. So all the compounds containing carboxylic acid, on treatment with sodium bicarbonate, you get brisk effervescence. Small bubbles. It is due to the formation of carbon dioxide. Looks like boiling, effervescence. And it is a characteristic property of COOH only. It may contain any number of carbon atoms, 2 carbon atom, 20 carbon atom, 200 carbon atom, any number of carbon atoms. So the compounds containing the COOH should have this particular property. It's a characteristic property of COOH. For example, you have an ester, a compound containing any organic compound containing ester group, they will have sweet smelling, they're all sweet smelling compounds. Therefore, they are used perfumes. They are used in perfume, synthesis of perfumes. So all perfume compounds, perfumery compounds containing esters, it's a characteristic property. Like that alcohol, aldehyde, ketone, they have got different characteristic properties. And that group of atoms and atoms which is characteristic of that particular compound is called a functional group. They signify the property. Why is it called functional group? Property means function. Function of the compound. Property of the compound. Therefore, functional group. Let me take the first example, simplest example, C2H6O. This is the molecular formula of the compound containing 2 carbon atoms and 6 hydrogen atoms, 1 oxygen atom. Now, it can be written in 2 different ways. For example, as I told you, the carbon can combine among themselves any fashion. And all the 3 carbon atoms can combine among themselves. And each carbon atom has got a valency 4. And one of the valencies is occupied in the OH because we have to account for this. This could be in the form of O. It could be in the form of an alcohol. The rest of them are going to be hydrogen, 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 hydrogen. And this is going to be the structural formula of this particular compound. You can write this as a condensed formula. CH3, CH2, CH2, OH is a condensed formula. Okay. Now we can write the bond line formula. There are different ways of writing the compound. If I put a dot here, it's single carbon atom. At line combining the 2 dots, it should contain 2 carbon atom, third carbon atom. We have CH3, CH2, and OH is going to be. This is the bond line formula. Anyhow, we are going to learn all these things later and in detail. Now, this way, the oxygen can be attached to the terminal carbon atom, or the oxygen can be attached. It can be connecting 2 carbon atoms together. It's carbon, carbon, and oxygen. So it is the oxygen that connects C2 on one side and C on the other side. Now indicate the valency of the carbon, the 4 here, and all. Since we have already accounted for oxygen atom, so we have to account for hydrogen atom. So how many hydrogen atoms? So 8 hydrogen atom, 3 carbon atom. C3H8 can be accommodated this way. And they are ultimately different. This is called an ether. The characteristic property of an ether, they are all volatile compounds, highly volatile compounds. Which compounds in organic chemistry are volatile? The one which has got a very weak force of attraction. Weak intermolecular force of attraction. Intermolecular force of attraction. We are going to understand and study this in detail, force of attraction. If 2 molecules are attracted very weak by means of weak force of attraction, and they are prepared to come to the vapor state much more readily, they are highly volatile. They have got very low boiling point. Ethers, and that is the characteristic of ether here. Whereas in the case of alcohol, this is an alcohol. This is an alcohol because it has got the OH group. It has got oxygen bond, single bond, oxygen, single bond. It's called an ether functional group. It is the oxygen. Therefore, 2 compounds, one consisting of the OH group alcohol can be represented, the other one ether. Therefore, these 2 compounds are called isomers. So both of them have got the same molecular formula, C3, not H6O. It is H8O. Sorry, please correct it. It should be C3H8O. And this is also, I'm sorry, in this case, I am not explaining this. In this case, it is right. In the previous case, okay. I was explaining to you C3H8O all around. Now, probably much simpler example is going to be C2H6O. The two carbon atoms can be combined together and oxygen could be attached to any one of the carbon atoms, and valency of oxygen is 2, therefore it has got to, so valency of carbon is 4. Therefore, it should be CH3, CH2, OH, and that is called ethanol. Ethyl alcohol is the trivial name. Ethanol is a EUPAC name here. Now, or the two carbon atoms can be linked together by means of an oxygen linkage. And this is called an ether. Each carbon atom satisfies the valency 4, being a terminal carbon atom CH3, here also CH3 and CH3. Therefore, the structural condensed formula is CH3O CH3, methoxymethane. It is also known as, it's a methyl group. CH4 is called a methane. CH4 is called a methane. If you remove one hydrogen atom, it becomes CH3 dash, because the valency is not satisfied, so we put a dash here. The dash can be one more hydrogen atom or any functional group like fluorine, chlorine, bromine, or OH here or COOH here, any functional group. Therefore, it is called an alkyl group. One hydrogen short of an alkane is called an alkyl. This is called an alkane, general molecular formula of an alkane. This is called an alkyl. Okay, so the alkyl group is methyl. Trivial name, there are two methyl group, dimethyl, therefore ether, dimethyl ether. Okay, another example is going to be C3H6O. C3H6O. This can be connected 3 carbon atoms together, all the 3 carbon atoms. Okay, but we have to account for one oxygen atom. You put hydrogen, hydrogen, third hydrogen, fourth, fifth, and we have already accounted for all the 6 hydrogen atoms. Now we have to account for the valency of the carbon. Carbon exhibits, we have satisfied only 2 valencies. Now we have to satisfy 2 more valencies. So hence we put a double bond, and this is called an aldehyde group. The structure of an aldehyde is going to be C single bond hydrogen double bond O. So this can be an aldehyde. CH3, the condensed formula is CH3, CH2, CHO. It has got 3 carbon atom. Propane is alkane. And all aldehydes end with Al. Propanol. Propanol. From the name itself, we can identify the nature of the functional group. If an aldehyde, if a molecule, if the name ends with OL, it's an alcohol. Ethanol, previous case, OL. Okay? And from the name itself, we can identify the nature of the functional group. If a name ends with ONE, for example, propanone, propane, I cut that E, put ONE, it's a ketone. It's a ketone. Now, that oxygen atom, look at this. The compound, all the 3 carbon atoms are linked together. That double bond O can be attached to the middle carbon atom. So the middle carbon atom, no more hydrogen atom, valency is already 4. And here it has to be only 1 valency, so I have to account for 3 more valencies. Here also only 1 valency I have to account for. This is the condensed formula of CH3CO, and in fact the structure of the molecule CH3, C double bond O and CH3 to account for the tetravalency. And they are, both of them have got the same molecular formula C3H6O. One is an aldehyde, the other one is a ketone. They have the different physical properties and different chemical properties also. Therefore, they are isomers. They are isomers. Another very interesting example, often asked in the competitive examination, either NEET examination, especially the NEET examination, glucose and fructose. Let us not be go into the structure of the glucose and fructose. Both of them have got the same number of carbon atoms, 6 carbon atoms, 12 hydrogen atoms, and 6 oxygen atoms. One is called the glucose, the other one is called the fructose. Because it has got an aldehyde group, whereas this has got a ketonic group. Probably should be in the middle. Ketonic group always, it's not a terminal functional group. This is the terminal functional group. It has to be attached to the one end of the carbon chain, whereas this has to be attached, this should be present in the middle of the carbon atoms. Therefore, non-terminal functional group. COOH is called a terminal functional group. terminal. OH group is a terminal functional group attached to the because already the valency is 1. Valency is 1. It can be attached to the terminal carbon atom or the middle carbon atom also. So glucose and fructose are isomers. This is called an aldehyde, and fructose has got the ketone. You know, fructose is the sweetest of all the sugars. Fructose is sweeter than sucrose. The cane sugar, it's an additional information for you. That's all. The cane sugar, white crystalline substance that we use in daily, in our day-to-day life, is called the sucrose. And this is fructose sweeter than sucrose, sucrose sweeter than glucose. And that is going to wait another question asked in the NEET examination. I shall give examples for the JEE main examination, whether this is going to be asked in NEET examination, whether this is going to be asked in NCERT also. So the above questions can also be asked, important questions in NCERT textbook. Is that clear to you? So anything which has got same molecular formula with different functional group. For example, let us not be worried about the IUPAC name. This is going to be, of course, I don't mind giving you the IUPAC name also. Propanoic acid, oic acid, all the carboxylic acid end with oic acid. Propane is the hydrocarbon, alkane. Propane is the alkane. And remove one of the hydrogen atom. For the sake of this, I want to write this one hydrogen atom separately. That hydrogen can be replaced by COH. No, the entire thing is going to be, this is going to be, sorry. You have the same number of carbon atoms, 3 carbon atoms, and the acid is going to be there, C double bond O and OH. This is the structure of carboxylic acid. The rest of the carbon atoms has got only hydrogen atom. Terminal carbon atoms always have 3 hydrogen atoms. The middle carbon atoms should have only 2 carbon atoms, and this is going to be propanoic acid. Now, probably I want to replace this hydrogen atom, this methyl group, interchange them, bring it here and bring it here. So, shall we write this? It is going to be already CH3, so it is going to accept one more hydrogen atom. It forms CH3, C double bond O. That hydrogen atom is replaced by a methyl. A methyl group, and these things can happen in organic chemistry, and then that is called the catenation, and that is the characteristic phenomenon of organic chemistry. And because of that, this is going to be an ester, sweet-smelling compound, whereas this is going to be a carboxylic acid, giving it a dense effervescence, brisk effervescence with sodium bicarbonate. Okay, it has got a fruity smell. Both of them have got the same molecular formula, C3H6O2. C3H6O2, C3H6O2, and the 2 oxygen atoms can be represented by this way. And both of them are called isomers. Why are they called isomers? Compounds having the same molecular formula with a different structural formula, they are called isomers. Isomers. Okay. Now, I shall go to the next one, chain isomerism. When I talk about the chain isomerism, I always refer to carbon chain. The carbon chain, I told you it has got the characteristic property of catenation, self-linking of atoms. I will just give you an example. You have 4 carbon atoms. 3 carbon, whatever way in which the 3 carbon atoms combine, there is no branch chain at all. Only one way. You can write them this way, you can write them this way, or you can write them this way. Okay, or you can write them this way anyway, but it is going to be all the 3 carbon atoms are attached continuously. Okay, so there is no branching here, no branching. Now, whereas the branching takes place with the C4 carbon atom. C3, there is only 1 carbon atom. So methane. C2 also, there is no branching. It is going to be 2 carbon atoms connected together. Propane, propane. Again, it is going to be C3 carbon atom only one way. If it is going to be C4, for example, I have the 4 carbon atoms in a straight chain, or of course, this can be written this way. It is equivalent to a carbon here, a carbon here, carbon here. But if you start with one carbon atom, you are able to touch the last carbon atom with a single stroke, one directly. You don't return back here. Or you can write it this way also. They are the different conformation, the molecular formula, structures of butane. But at the same time, you can have 3 carbon atoms. The branching can take place in the middle carbon atom. This is called a straight chain compound without a branching. This is called branched chain. Branch chain compounds. Branch chain compounds. It has got a branching, and branching always can take place in the middle carbon atom. You cannot say branching takes place in the terminal carbon atom. It is equivalent to writing all the 4 carbon atoms straight away. Instead of writing in a straight away, you have put it down. That's all. That's all. It is going to be a straight chain compound. Continuously, you are able to touch all the carbon atoms without coming back. Without coming back. That is a straight chain compound. Now, let us look at the examples of alkanes having the chain isomerism. As I told you, the chain isomerism starts from C4. Alkane. Alkane, the general molecular formula of an alkane is CnH2n plus 2. Alkene, CnH2n. Alkynes, CnH2n minus 2. You would have learnt it in 10th standard. So alkanes, C4H10, C4H10. And how do you write it? As I told you, there are 2 carbon chains, A, B, 3 plus 1. This is 4 plus 0. There is no branching. 3 plus 1, 3 carbon atom, 1 branching. As I told you, branching should always take place in the middle carbon atom. So these are the 2 skeletons for C4 carbon skeletons. Now, the formula is, this should be represented as CH3, CH2, CH2, CH3. This is called the butane. IUPAC name is butane. And trivial name, N-butane. N is the isomer of normal butane without branching. Normal means no branching. This is called, it's an isomer of butane. Therefore, it is also called as isobutane, or abbreviated as ibutane. If anything is written as ibutane, it means an isobutane. The IUPAC name of this particular compound, CH3, CH, CH3. I'm not going to discuss exhaustively regarding the IUPAC rules. For a simple compound, probably I can say this. Therefore, the longest chain contains 3 carbon atoms. 3 carbon atom alkane is propane. And this is going to be a methyl group. Methyl propane. Where should this methyl group attach to? Middle carbon atom. You start numbering from left to right or right to left. 1, 2, 3, or 1, 2. Either way, it is on the second carbon atom. Therefore, this is to be named as 2-methyl propane. 2-methyl propane. After methyl, there should not be a gap there. 2-methyl propane. Butane and 2-methyl propane are the examples of isomers. Isomers. And this is what is going to happen in alkanes. We are going to see a lot more examples among alcohols, alkenes, alkynes, etc. All functional group or type of compounds exhibit chain isomerism. They have different carbon chain. Among alcohol, for example, let me take C4H9O, OH. It's an alcohol. The molecular formula is C4H10O. The general molecular formula is CnH2n plus 2 for an alkane plus 1 oxygen atom. Now, this can be written as I told you. There are 2 carbon chains. One is going to be straight chain, the other one is a branch chain. I can have the OH group here. I can have the OH group here. So I'm able to get two alcohols here. One is going to be CH3, CH2, 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 OH. Pardon me if I don't give you sufficient time for you to copy, because at least the maximum part of this structural isomerism I want to finish. Otherwise, no, I'll be dealing with only one particular thing, namely functional isomerism or chain isomerism. Now, please listen to me how I explain, because the video is going to be with you. Please go home and revise it once again. Open up and try to revise it. It can be in the OH group, can be in the second carbon atom. If it is in the second carbon atom, instead of CH2, you have CH only, you put OH here. So that is going to be, there are two isomers. Now, compound 3, I can have the OH group here with the skeleton. So it should be CH, CH3, CH2, OH. Or I can have the OH group attached to this middle carbon atom, therefore it could be the fourth isomer. So the structural formula, the fourth isomer, CH3, C, OH. Let us not be worried about the IUPAC name or the trivial name. Okay, but anyhow, I want to tell you which of these two have got chain isomer, different carbon chain. The chain isomers, what are the chain isomers in this particular case? They should have the pair of compounds which have got different carbon chain. 1 and 2, because 1 has got normal chain, not 1 and 2, 1 and 3. 1 and 3, 1 has got the normal chain and 3 has got it. So this particular pair, 1 and 4, 1 and 4, this particular pair also, normal chain, branch chain. Again, 2 and 3, 2 and 3 is a straight chain, it's a normal chain. And 2 and 4, 2 and 4. So that could be one question here. How many pairs of, there are 4 pairs of chain isomers. Pairs of chain isomers. That could be one IIT question or NEET examination question. 4 pairs of chain isomers. 4 pairs of chain isomers. Okay. So that is going to be chain isomerism among alcohols. Chain isomerism among halogens. For example, let me take C4, H9, Cl. One of the hydrogen atoms of C4H10 is replaced by halogen. Chlorine. Chlorine is a functional group. As I told you, there are 2 carbon chain, 4 plus 0. The other one is going to be 3 plus 1. Now in this case, let us see. I can have it on the first carbon atom, as I told you. I can have it on the second carbon atom. Let me write only the carbon skeleton. Carbon, carbon, carbon. We have a chlorine. And as I told you, in this particular case, I can have it here. So you try to put that skeleton, put chlorine here. And the fourth one, I can put the chlorine in the middle carbon atom. You try to put the skeleton here and put chlorine here. The rest of them hydrogen atom. So this is the fourth compound. Which pair, which 2 of the compounds are chain isomers? Once again, 1 and 2. 1 and 3, 1 and 4, 2 and 3, 2 and 4, 2 and 4, 1 and 3, 1 and 4, 2 and 3, 4 pairs of chain isomers, 4 pairs of chain isomers for this molecular formula. Okay, they can give you this compound, ask you to draw the write the molecular formula. Of course, that is going to be an NCERT question. Is that clear to you, my dear students? I just want to know whether you have got posted any questions to me. So far, no questions. Now, we shall proceed further. Okay. Similarly, you can have it in Position isomerism. I shall do it slowly because of its importance. This and the next one is going to be very important. Now, probably I want to tell you number of chain isomers for C5, number of chain isomers. Normally I ask questions in the class, but want of time I am not asking you. We call them as buzzer round questions or skill based questions. Okay, the chain number of chain isomers for C5H12 alkane. Now they ask you 2 here, B 3 here, and C 4 here, and D 5 here. Let us see which of them is going to be the answer for this particular question. Which of them is going to be? For want of space, I shall write C5. How would you draw the C5? I can 5 plus 0. 0 because there is no branching. All of them in the straight shape. 4 plus 1. I can have the 4 carbon atoms and 1 branching. Now please note that this particular structure, skeleton, is equal to this particular, because they got the same IUPAC name. So they are one and the same structure, same IUPAC name. If you are going to put this methyl, this is butane, 2-methyl butane. Now we are going to, this is a methyl, this is a butane, but this has to be numbered from left to right only. There are certain rules. The substituent attached to a carbon should, the carbon containing a substituent should have bear the minimum number. So this should be 1 here, this should be 2. Always from right to left here. That way they have got the same compound. 2-methyl butane, 2-methyl butane, they are one and the same structures. Okay. Then 3 plus 2. How do you draw the 3 plus 2? I can have 3 carbon atoms, 1 branching down and 1 branching up. Probably you might think, sir, why not we have 3 compounds and branching here? This is again equivalent to 4 plus 1. See here, this is the longest chain and 1 branching 4 plus 1 here. Therefore, it should not be written this way. It has to be written separately, 2-methyl group, 2-methyl group. Therefore, how many isomers, carbon skeleton you have got? 3 isomers. They are called butane, pentane, A, and as a derivative butane, 2-methyl butane, and C, it's a propane, dimethyl propane. See here, there are 2 methyl groups. There's a methyl here, dimethyl, and the number should be attached to, written for each of the carbon atom. 2, 2. For each methyl group, we have to write the number here. This is the number of second carbon atom for 1 methyl. This is the number for the for second methyl group. 2, 2. How many methyl group? Multiplicity factor, dimethyl. On the whole, it's a carbon chain containing propane derivative. 2, 2 dimethyl. Therefore, there are 4 isomers. That way, you please go home and see how many skeletons are there for C6. You can try this, and that is going to be another NEET examination or main examination question. My dear students, we will go to another more interesting part of isomerism, position isomerism. Now, how did he define the, let us recall again, how did he define the functional isomerism? Same molecular formula and different functional group. Chain isomerism, same molecular formula, same functional group, because if you have different functional group, they are not isomers at all, isn't it? So it has to be same functional group. And different What is that we are trying now? Chainism, different chain, carbon chain. In the case of position isomerism, what we are going to discuss now, it has got the same molecular formula, okay, same functional group. What is the third one? Chain, same carbon chain and different position of functional group. You should be able to remember them for the definition's sake. Functional isomer, different functional group. Chain isomer, same molecular formula, same functional group, different carbon chain. Position, same molecular formula, same functional group, same carbon chain, but different position of this. Now, let me take the alkene, examples for the alkene. Alkenes are the compounds containing carbon-carbon double bond. Supposing you have got, there is no isomerism in the case of, what is the general molecular formula? CnH2n. If it is going to be C3H6, there is only one structure here. There are no two structures here, because probably you might think, sir, I put one double bond here and why not I put the double bond here? And please remember, they are the one and the same compound. Why are they one and the same compound? Because they have got the same IUPAC name. And we have to indicate the position. This is 3-carbon alkane is propane. With one double bond, it is called propene. This is called 1-propene. It is also 1-propene. It has to be, if it is numbering, of course, in this case, propene means 1-propene only. We are giving this number 1. Supposing you want to put another functional group, okay? So that way you have to give them, represent the number. Now we shall go to C4H8. How many alkenes are possible? First of all, let us draw the carbon skeleton. One is the normal skeleton, 1, 2, 3, 4. The other one is going to be in this normal skeleton. In how many places you can have this thing? I can have between the last carbon atom and the previous carbon atom, an ultimate carbon atom, or I can have the double bond between second and the third. There is only one double bond. This is called butane. Put that E, put ene. And prior to that, we have to put the number position of the double bond. But 1ene. Here, this is going to be butane. Cut that E, put ene, butene. Where is the position of the double bond? After the second carbon atom. But2ene. Or it is also identified as 1-butene. It is also identified as 2-butene. In some of the book, butene 1, butene 2. But this is the correct method. That is, this is the functional group. Ene means the double bond. And the position of the double bond should come prior to the functional group. Right. Now, we have got one more skeleton. Branch skeleton. In this, in how many places? You can have it only one place. What does it matter whether you are going to put the double bond here, or a double bond here, or a double bond here? My dear students, all of them are same compounds only. Same molecular formula, same IUPAC name. Because how do you name them here? This is okay. This is going to be, we have to take the longest chain of the alkene, 3. What is the 3-carbon alkene? It's called propene. And this is methyl, 2-methyl propene. 2-methyl prop. It's understood. It has to be prop 1ene. You don't need to say 1. It has to be 1ene only. This is carbon 1. Therefore, where is the methyl group? 2-methyl propene. And this is going to be, we have to take the longest chain containing the double bond. So 1, 2, 3, propene, 2-methyl propene. So all of them are going to be the same compound. Therefore, they are not position isomers. Now, I shall give them the number. This is going to be compound number 1, and this is going to be compound number 2, and this is going to be, there are on the whole 3 isomers. 1 and 2 are position isomers. Why? Because they have got the same molecular formula, same functional group, same carbon chain, straight chain. Whereas 1 and 3 and 2 and 3 are referred to as chain isomers because they have got the different carbon chain. The moment you have got different carbon chain, they should be referred to as chain isomerism. Chain isomerism. Is that clear to you? Let's see the position isomerism among alcohols. Among alcohols, CnH2n plus 2 is alkane, and you introduce one oxygen atom anywhere, so the molecular formula becomes CnH2n plus 2O. If it is an alcohol, because it can be an alcohol or ether, if it is an alcohol, it can be written as CnH2n plus 1 OH. Or it can be an ether also. It can be an ether also. Ether has got, let us not go into that. Okay? Supposing you have got C3H8O and we say it is an alcohol. 3,3 has got only one chain. There is no branch chain. There is no branching. Branching occurs only from C4 onwards. Please remember, there are 2 branching for C4, 3 branching for C5. I asked you to find it for C6 homework for you. Now, in this case, I can have the OH here, and that is going to be carbon number, compound number 1. I can have the OH here, and that is going to be. So, what is going to be the structural formula of compound 1? CH3, CH2, CH2. It's attached to the first carbon atom. Propan-1-ol. Look at this. Propanol. Propan-1-ol. That E is replaced by OL. It's an alcohol. What is compound number 2? CH3, CHOH, CH3. This is called propan-2-ol. Propan-2-ol. Interestingly, you will observe, even if you are not given the structure, probably you will be given only the IUPAC name. Identify from the following the position isomers. For example, among the various compounds, you have got a pair called propan-1-ol and propan-2-ol. Immediately, you should tell them that it belongs to position isomerism. Because position isomers will have the same name, because same functional group, same carbon chain, same name. But the position, the number alone is different. Propanol, propanol, 1 and 2 here. Therefore, compounds having the same name with different position as functional group are position isomers. Now, it is going to be very exhaustive for C4 carbon atom. Let us go into the C4 carbon atom, C4H10O. As I told you, there are 2 skeletons, 1, 2, 3, 4. I can have it here, the OH group here. I can have it here, second sets of compound. So 1 is going to be CH3, CH2, 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 OH. Compound 2, you can have the OH with second carbon atom, CH3, CH2. You can in fact start from here also, left to right, CHOH and CH. And I can have the skeleton, branch skeleton. There is one more skeleton. So I can have the OH attached to this particular carbon atom. This is the fastest way. You draw only the carbon skeleton and put arrow mark and put the numbers. That way you should be able to identify the total number of isomers. The fastest way of identifying. They can ask you to write the total number of isomers. This is the fastest way. Or I can have the OH group to this particular carbon atom. So this is going to be 3 here. This is going to be 3 here. And this is going to be 4 here. What is going to be 3 here? It is going to be CH3, CH, CH3, CH2, OH. What is going to be 4 here? CH3, C, OH here is attached to CH3 here and CH2. I shall probably give you the IUPAC name of the compound. IUPAC name of the compound. Butane 1-all, probably here itself I can write. I can write the here itself with a different name, different color. One is going to be butane 1-all. 2 is going to be, you write butane, cut that E, put all, that is an alcohol, put hyphenated. The number should be hyphenated on either side. Butane 2-all. 3. The longest chain contains 3 carbon atoms containing the OH. So propane 1-all. This is the methyl group. We should start numbering from right to left. The carbon containing the OH group should be given the preference 1, 2, and 3. Therefore, it is 2-methyl propane 1-all. Okay. In the NCERT, they give you the structure, ask you to identify the isomers. Okay. And whereas in the case of IIT main examination, they give you the IUPAC name. From that, you are asked to identify the chain isomers and the position isomers. We shall see. This is going to be the longest chain containing alcohol is the 3 carbon, propanol. It's on the second carbon atom, propane 2-all. It's a methyl group. It's on the second carbon atom. 2-methyl propane 2-all. 2-methyl propane 2-all. Now, we'll go back to the relationship. What is the relationship between 1 and 2? And that's an IIT question. What is the relationship between 1 and 2? 1 and 2 have got the same carbon chain. So, position isomers. The number alone, the name is the same, so they belong to position isomers. What about 3 and 4? 3 and 4, you can pair them together. Same name, number alone. Again, a second pair of position isomers. So there are 2 pairs of, I can ask you 2 pairs of position isomers. For this molecular formula, C4, let us come back to this a little later. For this molecular formula, C4H10O. Now, at the same time, you can pair them differently also. 1 and 3, 1 and 4, it's a different pair. 2 and 3, 2 and 4, they are all 4 pairs of 1 and 3, they have got different carbon chain. The moment you have got different carbon chain isomers, 4 pairs of chain isomers. Or they can ask you the ratio. The ratio between the number of pairs of position isomers to pairs of chain isomers. 2:4 or 1:2 or whatever may be the case. And that is an IIT question for you. IIT question. Asking you the relationship is going to be main examination question, and the NEET examination question asking you the IUPAC name is the NCERT question. Similarly, you can have it in the case of chlorine also. Same way. Is that clear to you? I shall just give you an example only. CH3, CHCl, CH3, CCl, CH3, now let me give you a simpler example first. CH2, CCl, and CH3. Can you tell me? Look at does it belong to functional isomers? or position isomers or chain isomers, look at that. They have got the same functional group, the same number of carbon atoms, same carbon skeleton, same carbon skeleton. Whether this is going to be this way or this is going to be this way, carbon skeleton is the same. And what is the IUPAC name here? We have to number them 1 because we have to give importance to the chlorine. Should have preference. That should carbon containing chlorine should have a least number than the other alkyl group. 2, 3, 4. So the longest chain contains how many carbon atoms? 4. Butane. This is a substituent. This is also a substituent. This is chloro. This is methyl, which should be named first alphabetical order, earlier alphabetical. Chloro, C for chloro, M for methyl. So 2 chloro, 3 methyl butane. Now in this case, 1, 2, 3, 4. This is a methyl. It is 2 chloro, 2 methyl. Both of them attached to the same butane. 2 chloro methyl butane, 2 chloro. This is 3 methyl butane. Number alone is going to be different. Therefore, they belong to position isomers. Position isomers. Or they can ask you this example. What is this isomerism exhibited by this? CH3, CH2, CH2, CH3. Sorry, I shall write because I want to ask you a separate question. CH2, CH3, and CH3, CH2, CHBr, CH2, CH3. Okay, they can ask you, of course, I'm not going to give you the IUPAC name. That means I can give you the answer to you. This belongs to position isomers or chain isomers or functional isomers, etc. You may have a different functional group. Chlorine here, the functional group. You may be tempted to write this is a functional group, but they are not isomers at all. And that is an IIT question, NEET examination question. Because why? Because they do not have the same molecular formula. Have the same molecular formula. One has got C5H12, H11Cl. This is C5H11Br. So they have got different molecular formula. So they are not isomers at all. They are not isomers at all. Okay. Now we shall go to the metamerism, and that is going to be very tricky and very simple. As I told you, the functional groups can be classified into monovalent functional group and multivalent functional group. The multivalent functional group can be classified as divalent functional group and trivalent. If you put a dash, only one dash, for example, OH, this is called a monovalent. Chlorine, all halogens can be written by this monovalent. And NO2, nitro group is monovalent. There is only one dash here. COOH, carboxylic acid, I put only one dash. CHO, I put only one dash. NH2, this is a primary amine. 1 degree amine is called a primary amine. All of them are few examples of monovalent. I have put. They can be attached to only one carbon atom. They can be attached to one carbon atom anywhere, the terminal carbon atom or the middle carbon atom. Okay. Now this is going to be divalent. Examples: ether. This is an ether. 2 carbon atoms. On one side a carbon, other side a carbon, or different alkyl groups must be attached here. C double bond O. A ketone is a divalent functional group, whereas aldehyde is a monovalent functional group, though they are functional isomers. COO or ester is a divalent functional group. NH dash and dash, valence of nitrogen is 3. Secondary amine is a divalent functional group. Nitrogen attached to 3 other carbon atoms, 3 other alkyl group. Tertiary amine. Tertiary amine is a multivalent functional group, but it is not a divalent, but it is an example of trivalent functional group. This is a trivalent function. Tertiary amine. Tertiary amine is a trivalent function. Now, this particular phenomenon, metamerism, is exhibited only by multivalent functional group. These a compound they can give you which among them do not contain for exhibit multivalent functional group. It's a metamerism. Compound alcohol, halogen compound, nitro compound, acid, aldehyde, all these things do not exhibit metamerism. Metamerism is exhibited by ether, ketone, ester, amine, and tertiary amine because they are all multivalent functional group. I have given you the examples for the monovalent functional group, divalent functional group, trivalent functional group. Now let us come to the definition of metamers. The central multivalent functional group is attached to a different alkyl group. For example, let me take ether. I got a CH3 here, O here, and C2H5 here, and ethyl and this. This does not exhibit whether you are going to change. It is equivalent to, it is not an isomer. They are the same compounds. They are not isomers. They are the same compound. C2H5, O, CH3. Of course, if O is going to be replaced by H, it's a functional isomer. Among the ethers, they are the same compound because they got the same IU pattern. For example, I got an alkyl ether on one side propyl, the other side 1. So I call this a 3+1 linkage. 3 carbon atoms on one side and 1 carbon atom on the other side. It is also possible for me to have 2 carbon atoms on one side and 2 carbon atoms on the other side. 2+2. 2+2. You don't call them as position isomers because they are not the same compound. For example, this is going to be propane, methoxy propane. It is ethoxy ethane. They are not the same position. Position isomers should have the same name. So this is methoxy propane. The skeleton for this is methyl CH3, methyl propane or methoxy. It's attached to the first carbon atom. 1 methoxy propane, and this is going to be the longest chain contains 2 carbon atoms. Ethoxy, ethane, and both of them are metamers because the central multivalent functional group attached to different alkyl group. In one side propyl and methyl, the other side ethyl and ethyl. I shall give you some more example for the before that a question here. I don't know how many of you are going to answer this particular question. How many of the following exhibit metamerism? I have given you 1, 2, 3, 4, 6, 7, 8, 9 compounds. How many of them exhibit metamerism? A, 8, B, all of them exhibit metamerism. C, 7, D, 6. To be on the safer side, none of the above. Supposing if this question is given to you, based on today's knowledge, you should be able to answer this. This is an IIT or NEET examination. How many of the following exhibits metamerism? And first of all, identify the functional group that exhibits metamerism. It's a monovalent functional group. Ketone is a divalent functional group. Aldehyde is a monovalent functional group. Carboxylic acid is a monovalent functional group. Ester is a divalent functional group. Primary amine is a monovalent functional group. Secondary amine is a divalent functional group. Tertiary amine, tervalent functional group. It's a divalent functional group. Now, 1, 2, 3, 4, and 5. None of the above. I told you to be on the safer side. I gave you that. So the answer is going to be the 5 of the compounds exhibit metamerism, or 4 of them do not exhibit metamerism. Did you understand? Based on the nature of the functional group. So generally, compounds with monovalent functional group, they do not exhibit metamerism. I'll see whether there are any other questions there. Oh, wonderful, wonderful. Oh, Janani, you have already answered it. Congratulations. In fact, I expected others also to answer this particular question. Okay. Now, I shall just give you only one question before we wind up today. One. Let's see how many of you are able to. What is the relationship between what type of isomerism for what type of isomerism is exhibited by CH3, CH2, CHOH, and CH3, and CH3, CH2, CHOH. There are how many carbon atoms? 5 carbon atoms. 1, 2, 3, 4. CH2 and CH3. Whether this is going to belong to chain isomerism. If you have understood today's class, you should be able to write chain isomerism. It belongs to position isomerism. C. Metamerism. D. Functional isomerism. Let's see how many of you are able to answer this question. Come on, let's see. Let us see. This is how we are going to learn organic chemistry in our guru. Okay? And normally it is going to be minimum 2.5 hours or so. Definitely we'll go very slowly and give a lot more examples for you. And let's see how many of you answered this particular question. How many of you have answered this particular question? Again, I shall read out the names of those students who have written the correct answer. I write the names of the students who have written the correct answer. Janani, you went wrong this time. If they have got different carbon chain isomers, if we have multivalent functional group metamerism, different functional group functional isomers, and let's see who has written the correct answer. The correct answer you have not given me the answer. Starts chain isomers. They are not chain isomers. Please listen. Please listen. They belong to position isomers. Same carbon chain. Straight chain carbon. Straight chain carbon. The position of the functional group, it's on the second carbon atom, pentan 2 all, pentan 3 all. So they are the examples of position isomers. Okay, is that clear to you? Wonderful. Don't worry. In the coming classes, we will learn more of organic chemistry slowly, and our we are going to score very good marks ultimately in the main examination in chemistry and organic chemistry. Okay, that is there any other question, Amenta, Satishwari? Is there any other question raised by the students? No other doubts. When you say no other doubts, so whatever you taught, it was crystal clear, sir, no doubt. And another way is, sir, there is no doubt. We have not followed head or tail of what you have taught today. Do I take it for the first case or second case? Kavya, you have written it correctly. Wonderful. Wonderful. It's a position isomerism. Okay. From students, we did not get any doubts, sir. Wonderful. Wonderful. No problem. No problem. Shall we wind up? Is it the time or shall continue? Can I continue further? Satishwari, should I? No, sir, up to 6 p.m. only. I have to definitely obey you. Thank you, mentor. And good night, my dear students. We'll learn more of organic chemistry, very interesting part of chemistry, namely organic chemistry. And our strong fort is going to be organic chemistry. We will make it. We'll prove it also. Good. All the best. Best of luck to all of you. Thank you. Bye.